Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse of a function. What is an inverse function? An inverse function is a function that will undo anything that the original function does. For example, we all have a way of tying our shoes. Am I right? And how we tie our shoes could be called a function. So, what would be the inverse function of tying our shoes? The inverse function would be untying our shoes. Am I right? Because untying our shoes will undo the original function of tying our shoes. This is a very basic example. Okay. This is a real life example. Let's look at an inverse function from a mathematical point of view. Consider the function f of x equal to 2x minus 5. If we take any value of x and plug it into f of x, what would happen to that value of x? First, the value of x would get multiplied by 2. Am I right? Because if you replace some number here, it will be multiplied by 2 because 2 is the coefficient of x. Then we would subtract 5 because this is the function f of x. The two mathematical operations that are taking place in the function f of x are multiplication here and subtraction. Now let's consider the inverse function. What two mathematical operations would be needed to undo f of x? Division and addition. Am I right? Because addition is the opposite function for subtraction and division is the opposite function for multiplication. Division and addition would be needed to undo the multiplication and subtraction because these are the opposite operations. A little farther down we will discuss how to find the inverse of the function, and I'll show you the steps. Hopefully the inverse function will contain both division and addition. I'll show you some example. So we should know how to notify an inverse of a function. So I'll show you what is the notation. F of x is the term that we use to represent a function. Then this notation f inverse of x, you can read this as f inverse of x, will be used to denote the inverse of f of x. Similarly, we can also see the notations like g inverse of x. You may be using several other variables to denote the inverse, but this is how the notation should look like. The variables can change, but it should be with an inverse sign and an x. Also, I would like to tell you f inverse of x is not equal to 1 over f of x. Because in laws of exponents, we would have read that a negative exponent is nothing but the fraction. In case if you move the negative exponent from the numerator to denominator, the exponent will change into a positive one. That thing will not work out here. So you have to note down this f inverse of x is not equal to 1 over f of x. So it is very important not to confuse this function notation with negative exponents. When we are talking about the inverse of a function, there arises a question: does all the function have an inverse? Not all the function have an inverse. So it is important to determine whether or not a function has an inverse before we try and find the inverse. Okay. So if a function does not have an inverse, then we need to realize that the function does not have an inverse, so we do not waste time trying to find something that does not exist. So how do we know if a function has an inverse? To determine if a function has an inverse function, we need to talk about a special type of function, which is nothing but one-to-one function. A one-to-one function is a function where each input, I mean the x value, has a unique output, that is y value. To put it another way, every time we plug in a value for x, we will get a unique value of y. I'm taking the very same example. So f of x, every time you plug in different x values, you will get a unique y. Am I right? So hope you remember the definition that I gave you for one-to-one function. Each and every term in this function, in this set, will be having exactly one element in the other one. Okay. So if I say the definition of one-to-one function in this term, you can say that every time we plug in a value for x, we will get a unique value of y. same way, y value will never appear more than once. Am I right? Therefore, a one-to-one function is a special case because only one-to-one functions have an inverse function. Please note down this clue. Okay, now let's look at few examples that will help demonstrating what a one-to-one function is. I'm just going to show you one simple example so that I could recap what is one-to-one function here. A function, please look at this example. A function f is one-to-one function because each of the y values in the ordered pair is unique. Am I right? 3, -5, 11 and 4. No repetition is here. So none of the y values appear more than once. Since the function is one-to-one function, the function must have an inverse. So this is how you could come to a conclusion that a function has an inverse or not. In case if it is not a one-to-one function, you need not proceed with your work because it will definitely not have an inverse. So it is a mere waste of time finding going in search of something which does not exist at all. Okay. Is the function a one-to-one function? We can determine if functions are one-to-one by looking at the ordered pairs and determining if each of the y values are unique. But what if we do not have an ordered pair? We could create ordered pairs by plugging different x values into the function and finding the corresponding y values, giving us some ordered pairs. Can you follow? So in case if the ordered pairs are not given, we can create ordered pairs by plugging in different x values. If you plug in different x values, definitely you're going to get some corresponding y values. So you can make pairs from these. For x values, you can just assume as how we do in t-charts. Rather than spending time creating ordered pairs, why not consider looking at the entire graph of the function instead? By looking at the entire graph rather than a few points, we should still be able to determine if the function is one-to-one function or not. So, in looking at the graph of the function, we can determine if a function is a one-to-one function or not by applying the horizontal line test. You would have come across this word, I guess. The horizontal line test. We used to denote it by HLT. It says that a function is a one-to-one function if there is no horizontal line that intersects the graph of the function at more than one point. It means it should cut the graph exactly at only one point. In case if it intersects the graph at many points or more than one point, then the graph fails the horizontal line test. So it cannot be a one-to-one function. So by applying the horizontal line test, not only can we determine if a function is a one-to-one function, but more importantly, we can determine if a function has an inverse or not, because that is what we want. So once you confirm it is a one-to-one or not one-to-one, you can understand that whether the function has an inverse or not. Hope you're clear with horizontal line test. Okay, I'm going to show you some examples or one example that will explain horizontal line test. Here is an example. Determine if the function f of x equal to -3/4x plus 2 is a one-to-one function. So to determine if f of x is a one-to-one function, we need to look at the graph of f of x. Since hope you know the difference between linear equation and the exponential equation. So what type of equation is this? Yes, this is a linear equation. The graph of f of x is a line with a slope -3/4 and the y-intercept is 0,2 here. So I have drawn a graph for this one. In looking at the graph, I'm going to draw a horizontal line to check the test. So in looking at the graph, you can see that any horizontal line, you can draw as many horizontal lines you want. So drawn on the graph will intersect the graph of f of x only once. Am I right? It is touching only at this point. No other point is touching. So therefore f of x is a one-to-one function and we are sure that f of x must have an inverse. Am I right? So what will happen if the horizontal line test fails? Please look at this graph. I'm going to draw a horizontal line and let's check. Did you notice that this horizontal line touches the curve at 2 points, more than 1 point? Am I right? So this graph fails the horizontal line test. So this cannot be a function. This cannot be a one-to-one function. So obviously this function f of x has no inverse. Does this make sense to you so far? So far we discussed whether the function has an inverse or not. Now let us see how to find the inverse of a function. Note that we have discussed what an inverse function is, the notation used to represent inverse function, one-to-one functions, and the horizontal line test. We are ready to try and find an inverse function now. Now I'm going to give you the steps. Here are the steps required to find the inverse of the function. Step 1. Determine if the function has an inverse by any of the before discussed method. Is the function a one-to-one function? If the function is a one-to-one function, we can move on to the step 2. If the function is not a one-to-one function, then say that the function does not have an inverse and you can stop the process. Okay. Once after confirming whether a function is a one-to-one or not, we can move on to the step 2. You have to change all f of x to y. And then step 3, switch all x's to y and y to x. And then you have to solve for y algebraically, as how we isolate for a variable. And then finally, after all simplification, all solving, you have to change y back to f inverse of x. So by following these 5 steps, we can find the inverse function. Please make sure that you follow all the 5 steps. Many people will skip step 1 and just assume that the function has an inverse. However, not every function has an inverse, because not every function is a one-to-one function. Do you all agree with me? Only functions that pass the horizontal line test are one-to-one functions, and only one-to-one functions have an inverse. So in our next video, we are going to see problems and apply all these steps. In case if you have any query, kindly let me know. See you in the next video. Have a great time ahead. Thanks for watching.